Good morning. Good morning, everyone. Today we are discussing kinematics, and in this video lecture, this is going live. Analyze the graphical representation of motion and equation of kinematics. How it is possible? Let's see few important things. Earlier we have distance, speed, etc. And these terms have a very important there in their concept as what is the displacement. Minimum position between 2 points is known as displacement. Displacement always in the specific direction. Displacement always will be in specific direction, and distance is not in the particular specific direction. If we think to see how can we explain displacement. Displacement are in a specific direction. Means if we consider a triangle, this triangle A, B, C. AC have a specific direction. AC have a specific direction, and here AB to BC is termed as a distance. The condition to get the direction north, south, west, east, origin. Here AC have a specific direction west north, and this direction is termed as north east, and this is west south and south east. So if you consider AC in the west north direction, so and this is also minimum position between 2 points according to Pythagoras theorem, perpendicular base and the hypotenuse. Then h square equal to c square plus b square. So this is the minimum position between 2 points. Displacement have a some property. It can be negative, positive, or zero because we need measure the displacement, distance, direction and magnitude. The vector quantity, quantity which is vector is need to magnitude plus direction. So here displacement. Practical example of displacement is air roots. Air roots is known as the displacement because air roots always set a minimum position between two cities, two countries. If we analyze the air routes in our practical concept, then we see always set a minimum position. So this air routes are displacement. Circular motion, in circular motion, diameter A, B. This is the minimum position between 2 point A and B. If we consider here circumference is 2 pi r. 2 pi r is a circumference and it is distance. And AB is the minimum position between 2 points and it is diameter. So it is displacement. A to B and then we come B to A. In one circular motion, in one circular motion, the total distance is 2 pi r and displacement is 0 because when we go up AB and then we come down, this is BA. And in the both cases, magnitude are same. So it is known as equal in magnitude AB equal to AB. When we add, we get the 0. So in one complete cycle of the circular motion, total displacement will be 0. So here average velocity will also 0. Now discuss the time graph. Typical different topic graph. How can we show here graph? Graphical representation. Kinematics is known as the study of the motion. So here we represent the motion of any particle through graph. This is known as a explanation of kinematics by graph. Here we need to define motion. Motion need to define distance or displacement and time. Therefore, we have two quantities. One is independent, one is independent, other is dependent, other is dependent. Independent, the quantity which is independent always represent on x-axis. Quantity which is always independent always represent on x-axis. And the quantity which is different is known as distance, displacement, acceleration. And this will be always at y-axis. Means to represent the time is independent on x-axis and displacement, velocity, and acceleration. Displacement, velocity, and acceleration. All are dependent. Means displacement, velocity, acceleration. All these three quantities are dependent. So we always represent on y-axis. So let's see the first graph, position time graph of the body. Position time graph of the body. what is the position time graph? Position time graph. ST graph. ST graph. What is the ST graph? You just need time and you next is the position or displacement. Okay. So look this graph. This graph shows the rest condition of the body. Why? Because in a particular position, yes, displacement. Time is always changing, but positions are still remain unchanged. Positions T2, T3 at T1, T2, T3. At T1, T2, T3, and all, we just looking the same displacement S S S. So here the velocity is zero. V is zero. So particle are in the condition of particle are in the condition of rest. Now next graph means here the conclusion, if in position time graph the line is parallel to time axis, then this is represented the rest state of the body, rest state of the particle. Second will be time position this graph. Time is constant. Time is constant always, but displacements are changing. It is not possible. It is not possible that time is not changing, but displacement is continuously changing. Here the angle is 90 degree. Here the angle is 90 degree, and this graph shows the velocity of particle is infinite. Velocity of particle is infinite. V equal to infinite if in position time graph, if in position time graph is not next. But time and position graph, this angle and this gradient, this gradient explain the velocity of the particle in position time graph. Always angle theta. And if you think at this point also angle is theta. Means angles are remains are remains unchanged, and therefore this graph shows the uniform velocity. This graph shows the uniform velocity. Now How can we say this is the uniform? In the mathematics, we try to explain position. Y-axis is T, 0, or C is equal to 0, then S equal to empty. And M, M is the gradient, M is the gradient or slope, and here displacement upon time. Therefore, conclusion of this position time graph, slope of position time graph gives velocity. Very important. Slope of position time graph is gives velocity. Time theta 1, theta 2, theta 1 greater than theta 2, theta 1 greater than theta 2, A, B. So, VA greater than VB. VA greater than VB. Greater the slope with time axis. Greater the slope with time axis gives the greater velocity. Theta 2, so the velocity of body A B. And if there is an angle, then time velocity flow must be higher to be have a greater velocity. And tan theta equal to V. This is the formula. This is the formula to get the velocity of any body by flow. Tan theta equal to V. And you also write here V equal to S by T. And this is equal to tan theta. Velocity of body A is the 1 unit. Okay, then VA equal to 1 and simply for V then 6 equal to regarding this slope of position time graph gives velocity if slope is 1 and it will be uniform non-uniform velocity of the body. This shows the variable velocity. This graph shows the variable velocity and velocity we need to draw the tangent. That's velocity. If you draw tangent. In our next stream, we will discuss our from this topic. Thanks for watching. Now, next stream will be continue tomorrow from this topic. Thank you.